for 12.7, let's move into some rules here. Now, we have that x and y are two numbers, then we can raise them as long as we use the same base. B to the x is equal to b to the y. Remember, that's how we actually started solving for exponents. Now, I also have a rule that we used before. As long as they have the same base, so if I have b to the x is equal to b to the y, as long as there's the same base, I can just let the exponents equal each other. Now, if x and y are both positives, we can also use the logs, right? Log of any base of x is equal to log of the same base of y. And vice versa. If x's and y are both positives, and I have that log base b of x is equal to log base b of y, notice I have the same base. I'm just going to say x is equal to y. Right? Those are rules that we have. Okay, so let's take a look at something here. Want you guys to approximate the solution to 3 decimal places. Now here, if I could do 3 to something is equal to 12, I just let the x's equal each other and that's great. Unfortunately, I cannot. Now, my problem here is my x is my exponent. So I remember I covered a way of how to bring the exponent down. That's if you do logs to both sides. So if I do the log to this, and I do the log of this, I have to get that x times log 3. Remember, the exponent comes to the front is equal to log of 12. So I did the logs to both, just so I could bring the exponent to the front. All right, so I have that x is equal to log of 12 divided by log of 3. Right, I'm going to divide both of my sides by log of 3. By all means, please do me a favor. Do not cancel the logs, the word log, and do not simplify 12 divided by 3. Do not simplify that. Literally type in log of 12 divided by log of 3. I'm going to grab my calculator. Log of 12 divided by log of 3. Let me erase this right here. Log of 12 divided by log of 3. Remember, I have to do 3 decimal places. My 8 is big enough. I'm just going to call this 2.262. Okay. One rule. Want you guys to please not forget. I had log of 12 divided by log of 3. Do not do log of 4. Like I said, do not cancel the divide the 12 divided by 3 because log of 4 is 0.6021. Notice how I get a whole different answer. So do not simplify the 12 over 3. Literally do log of 12 divided by log of 3. And also do not cancel the logs, because 12 over 3 will give me 4. So literally type in log of 12 divided by log. Okay. Let's move on. You try this. You should end up getting your x is about 3.170. Now here, remember I said earlier, if you see an e, the number e, the log you're going to be using is ln. So in this case, I'm going to do ln of each. So I have that 0.003x ln of e is equal to ln of 40. Let me remember a rule. Remember how we used to do log base, I'm going to call b, of b to the r. Remember how we used to say this is just equal to r? Because this whole thing cancels out. Didn't I say earlier that ln, the base is e? So isn't this just log base e of e? that whole thing is cancels out. It's just 1. So I have that 0.003x is equal to ln of 40. So I'm just going to say that my x is equal to ln of 40 divided by 0.003. All right, I'm going to divide both sides by 0.003. So I have ln of 40 divided by 0.0003 is that. I have to run it to 3 decimal places. I do see my 4th decimal number. It is a little too small. So I'm just going to call this 1,229.626. Now you try this. You try this at home, and you should get your t is about 96.758. Here I did it to 3 decimal places. All right, so let's solve this out. Give the exact solution. Okay, so I already have a log, but I only have it on one side of the equal side. So I remember how to write this in exponential form. I have a 2, a base 2, and my exponent is 4. So let me write this as 2 to the 4th is equal to x plus 5 to the 3rd. I'm going to write this in exponential form. I know 2 to the 4th. I can grab my calculator and go 2 to the 4th. Or I can literally multiply 2 times 2 times 2 times 2. That happens to be 16. I have that 16 is equal to x plus 5 to the 3rd. Now, how am I going to undo an exponent? Just do a radical. But in this case, do a cube root. So I have the cube root of 16 is equal to x plus 5. Let me subtract the 5. So I'm going to have that x is equal to negative 5 plus cube root of 16. Before, a few sections before, a few chapters before, we learned how to simplify radicals. The cube root of radical 16. I'm thinking 2 to the 3rd is 8. That's a perfect cube. So I can write this as cube root of 8 times cube root of 2. All right. So 2 to the 3rd is 8. So the cube root of 8 is 2. And then cube radical 2. So I'm going to write this as x is equal to negative 5 plus 2 cube root of 2. Make sure you simplify your radical. Now this is for you guys to try at home. And that's what you guys should get. Let me try this out. I see a minus in between 2 logarithms. Didn't we learn that how to condense that? So let me just call this log base 2 of x plus 1 over x is equal to log base 2 of 7. Where I condensed because of the minus, I wrote it as a fraction. I noticed that both sides are log base of 2. So I'm just going to say, I'm going to call this x plus 1 over x is equal to 7. Let me get rid of fractions. I'm going to multiply both sides by x. So I have that x plus 1 is equal to 7x. Let me subtract an x on each side. So I have that 1 is equal to 6x. So I'm going to say x is equal to 1 over 6. Now this is for you guys to try. Keep in mind that now I have a plus, so when you condense it, make sure you condense it as multiplication. You should end up solving that x is equal to 3. Now let me work this one out. I have a plus in between my logs, so I'm going to condense it as multiplication. So let me call this log of x times x minus 21 is equal to 2. Now I only have a log on one side, not both sides. As a matter of fact, I can do one thing. I can just call this log of x squared minus 21x equal to 2. So I multiplied. Now, once again, I only have a log on one side. So I know the log, if I don't see a number, it's log base 10. And the reason why I remember my base is because I want to write this in exponential form. Let me rewrite this as 10 to the second. Right, here's my base. Here's my exponent. So that's why I call it 10 to the second is equal to x squared minus 21x. I know 10 to the second is 100. So I have 100 is equal to x squared minus 21x. I know when I have an x squared, it's nice if I move everything to one side. I'm going to try to factor it. So let me subtract 100. So I have that 0 is equal to x squared minus 21x minus 100. Now I'm thinking two numbers multiplied equals negative 100. When I add them, it's equal to negative 21. I'm going to factor this as x minus 25, x plus 4. Remember, I was thinking two numbers that multiplied equals negative 100. When I add them, equals negative 21. That's how I got my negative 25 and positive 4. Now I'm going to have to let each of my parentheses equal to 0. So I have that x can be 25, x can be negative 4. Okay, now when I look at my problem originally, I have a log. I have a log of x. I can do log of 25. I can type that in. But I cannot do log of negative 4. Right? I cannot do logs of negatives. So x equals negative 4, I cannot accept that answer because I cannot do logs of negatives. So in this case, my only answer is 20. I cannot accept negative 4. Now you guys try this at home, and you guys will be solving that x is equal to 1. Now we're going to solve a logarithm equation. So a couple of rules here, but let's move on to compound interest. If a principal of $P is deposited at an annual rate of interest R, compounded n many times per year, the account will contain A equals P times 1 plus R over n to the nth dollar after T years. In this formula, what we're going to be doing is the P is what we start with. We're going to call that the principal. How much do you start with? Now, this could be that you're going to deposit money in your bank. Right now, banks are paying about 0.0000 nothing percent when you do either checkings or savings. Now you can invest money. This is actually for my business majors. You guys are going to be dealing with this. You guys are going to talk about investments. Now, this is when you deposit money, but what about when you borrow money? If you have a mortgage, you're buying a car, you're still making payments. You're dealing with what we call compound interest formula. Now, the principle is how much did you borrow? How much did they give you if you have a loan? Now, if you deposit into investments, how much did you deposit? Okay, so my R is going to represent rate. which we talk about percentage. We're going to write it usually as a decimal. Don't forget to move the decimal place 2 places to the left. Now, n is going to represent numbered compounded. So if I compound the interest twice a year, my n is 2. If I compound it monthly, so there's 12 times a year, my n is 12. There's this thing that we call semiannually, so 2 times a year, so my n is 2. So my n is how many times is a number compounded in a year. So in my exponent, my n is the same thing, my same n, but my t is going to represent years. So my t here, I'm going to call time, which is how many years. So let's remember that formula. We're going to be using it a lot. So let's take a look at this. I'll ignore my calculator. I didn't want it to come out so early. So how much money will there be in an account at the end of 5 years if 1,000 is deposited at 3% compounded quarterly? Assume no withdrawals are made. So my amount at the end, I start with 1,000. So 1,000, 1 plus, my rate is 3%, so I'm literally going to go 0.03. Compounded quarterly, so 4 times a year. My n is 4. And my exponent is going to be 4 times 5. Right? My n, I compounded quarterly, so 4 times a year. My t is 5 because I have 5 years. Now notice how I typed it all this on a calculator. I literally went 1,000 times, inside parentheses I did 1 plus 0.03 divided by 4, close parentheses. And then I used the little caret, the little arrow thing, we call that caret, to do an exponent. But make sure on the top, 4 times 5, you also put it inside parentheses. Because if you don't, the calculator will think that you're doing 1,000 times 1 plus 0.03 over 4. If you don't use your parentheses on the 4 times 5, it's going to do to the 4, and then it's going to do times 5 here, which is not what we want. So make sure that 4 times 5, you put it inside parentheses. All right, so I typed this on my calculator. Usually when we talk about money, we run it to 2 decimal places. I see my third decimal place is a 4, so I'm going to ignore this. And I'm going to say at the end of those 5 years, I'm going to have $1,161 with 18 cents. So I started with 1,000. If I get compounded quarterly at 3%, at the end of the 5 years, I have $1,161 with 18 cents. So you guys can see how much money I made. Obviously, 3% is a really low interest, but like I said, banks right now are paying about 0. Not even at 1%, 0.0000 nothing percent. So that's how much they're paying. So just for you guys to think about this. Now you guys try this at home. There's the formula. I'm reminding you guys of your formula. And you should get that at the end of 10 years, you will have 12,836 with 92 cents. All right, let's continue with this formula. Suppose inflation is averaging 3% per year. To the nearest 100, how many years will it take for prices to double? All right, so we started with an amount of 1,000, right? That's how we started everything earlier. So I want everything to double. So I mean that I want 2,000 at the end. So I want things to double is equal to the 1,000 that I started with to begin with. And then I have 1 plus. Now it says the averaging rate is 3%. So I'm going to say 0.03 per year. That means that it's compounded 1 time a year. And then on my NT, on my exponent, my N is 1 T. So 1 times T. I don't know the T. I don't know the time. Because it's asking me how many years will it take for the prices to double. To begin with, I can divide both sides by 1,000. All right, to make things easy, I'm going to cancel that out. So I have 2,000 divided by 1,000, I have 2. So I have that 2 is equal to 1 plus 0.03 to the t. And notice how I did 0.03 over 1 is just 0.03, right? And then 1 times t as my exponent is just t. So I can say that I have 2 is equal to 1.03 to the t. All right, I combine my parentheses 1 plus 0.03. Isn't that 1.03? Okay, so I wish I knew a formula how to bring the exponent down. How to solve for an exponent where the exponent is down. That's when logs come into effect. I have that log of 2 is equal to t of log of 1.03. Remember, I'm going to do logs to both sides, but the t, the exponent, comes to the front. So I'm just going to say that t, let me divide both sides by log of 1.03. Now I'm literally going to type that in on my calculator. Log of 2 divided by log of 1.03. So log of 2 divided by log of 1.03 equals, I'm going to call this my t. In this case is 23.45. So in about 23 years, if the average is 3%, in about 23.45 years, my investment is going to double. Now you try this. Find the number of years to the nearest 100. It will take for the amount deposited in an account paying 2% interest compounded semi-annually. So notice I say compounded semi-annually. So it gets compounded twice a year. I want this amount to double. And you should end up getting that t is about 34.80. Now, what if it doesn't get compounded a month, every month, or it doesn't get compounded twice a year? What if, now this is a little more accurate in when it comes to money in the bank. Compounded every month is basically mortgages or loans for the card. Now, compounded continuously, that's how it is every time in the bank. Now, if you deposit money. Now, we have a formula. A equals P. So my P, once again, is principal. My E is my number E. You remember we talked about the Euler number earlier. It's about 2.7. My R is going to represent rate. And my T is going to represent time. So I want to use this formula. Let's talk about this in example. There's one with the formula given. In example 6 earlier, we found out if 1,000 we invested for 5 years at 3%, compounded quarterly, so compounded 4 times a year, it will grow to 1,161.18. We did that earlier. Now, how much will this investment grow to if it gets compounded continuously? So my amount, the amount is I'm just going to say, I start with 1,000. I'm going to say E to my exponent is going to be, the rate is 3%, so 0.03. And then my T, my years, is 5. So I literally want to type this in. I'm just going to type this in. 1,000. I type in times E, but my calculator recognizes it as 2.718. But that's E. So if you notice, I have 1,000 times E to notice inside parentheses for my exponent, I did 0.03 times 5. So I just typed it as on the calculator. So doing it continuously, I happen to get 1,161.83 dollars. Right, my 4 was not big enough, so it didn't increase it. So If it was compounded quarterly, compounded 4 times a year, my amount is that. If it gets compounded continuously, that's my amount. So it does matter how many times it gets compounded a year. Once again, business majors, you guys will be dealing with this a lot. Now let's take a look at this. How long would it take for the initial investment amount to double? So remember, I'm dealing with 3%. My previous question, I was dealing with 3%. I want to know how long is it going to take for this to double. So I'm just going to say, well, if I'm starting with the 1,000, I want the amount to be 2,000 because it's going to double. Initially, I started with 1,000 e to the 0.03 times t, so I don't know the time. Let me divide both sides by 1,000. 2,000 divided by 1,000, that's 2. So I have that 2 is equal to e to the 0.03 t. So I'm just going to say, since I have an e, let me use ln. So I have that ln of 2 is equal to 0.03, because remember, once I do the ln of both, the ln of e cancels out, so I just have ln of 2 is equal to 0.03t. So for me to solve for t, I'm going to divide both of these sides by 0.03. So I'm just going to type this in. ln of 2 divided by 0.03. I'm going to say that my t is about 23.10. So in a little more than 23 years, my amount doubles, as long as it is gaining a 3% rate a year. So it takes about 23 years to double. Now, our calculators only have log base 10 and log base e, which is ln. That's what our calculators have. They only have log base 10 and log base e. But what if we have something that is not either base 10 or base e? So let's say that I have log base a of x. A is any number by 1. The way I'm going to do this, I'm going to do log base b of x. So I'm just going to call this log base 10 of x divided by log base 10 of a. I could do a log, or I could even do ln of x divided by ln of a. Let me show you guys an example of what I mean with this. So use the change of base to approximate to 4 decimal places. I'm just going to use, in this case, log base 10, because my calculator can do log. So I'm just going to type in, the way I see this is log of 12 divided by log of 5. Now, if you have one of those calculators where you can change the base, just type in log base 5 of 12. Now, if you don't, do this, log base 12 divided by log base 5. I type it in my calculator. I want to approximate it to 4 decimal places. Now my 5th decimal place is big enough, so it pushes the 9, but the 9 ends up pushing the 3. So I'm just going to call this 1.5440. Now this is for you guys to try at home. Now for this, you could use, once again, you can try log of 17 divided by log of 3. And that's how you guys are going to get this. But if you guys also want to try ln of 17 divided by ln of 3, it also works. You guys can try it with either log or ln. Either one will work. I have example A using logs and example B using ln's.